Alright, today's lesson is on composition of transformations. So we're going to go ahead and work with all four transformation types. You're going to do multiple ones in a problem. So composition of transformations is any combination of a reflection, rotation, translation, or dilation. The new image could be similar, which is a non-image transformation, or congruent, which is a rigid transformation. Alright, that's the first point we're going to actually talk about, especially with our first problem. So it has what transformations or dilations have occurred. And the first thing you need to also think about too is when you do these, is it similar or congruent? We know that congruent is same shape, same size. It's just a shape that is flipped, rotated, moved. So there's no size change there. Our similar is our same shape, different size. So that's when we see a dilation occurring. So we always want to look at first when we do these is, do I see a dilation there? And there is none. Our shape is the same size. So we're going to just cross dilation out. Okay. So now I'm going to be working with translation, rotation, or reflection. Okay. All right. And the first one that I notice here is I have A, B, C, D, and it turns to C, D, and then A, B. One of the things I notice is that my CD and my CD prime over here are kind of flip-flopped. Okay. So the one thing I'm going to go ahead and do, well, not flip-flops, but you'll see when we get there. Sorry. So the first thing I'm going to do is I notice that this shape right here, my pre-image, needs to kind of move over this way. All right. So I need to be able to move it over this way. So I'm going to go ahead and translate it. Okay. I'm going to move it over to here. Okay. So my C is going to go over 1, 2, 3, 4, 5, 6, 7. My D is also going to go over 7. 1, 2, 3, 4, 5, 6, 7. So I have my C and my D. I'm going to move these over as well. 1, 2, 3, 4, 5, 6, 7. And then my B also moves over 7 as well. So I've translated over by 7, you could say left. That's my first transformation I'm going to go ahead and do. I'm going to put a 1 here because that is just my first transformation. So now that I have it over in this quadrant, it looks like I have a reflection going on, and it looks like it reflects off my x-axis. So we'll notice that my C goes down 2 and then goes 2 to my C prime. D goes down 2 more to my C prime. Go down 6 and then 6 more to B prime. Oops, it should be B. And then A goes down 6 and 6 more to here. So my two forms of transformations is translate 7 to left and reflect on my x-axis. And if I look at my final question, are the figures similar or congruent? My final question is, or my answer is congruent. They're same shape, same size. I've just slid one over and then I've reflected it. Let's take a look at number 2. We have what transformations and or dilations have occurred. Alright, one thing I do notice right away is that my shapes, my pre-image and my image is smaller than my pre-image, which means I know I'm going to have a dilation in there. Okay? So if I look at this, to make it this size right here, notice how my B prime is 3, 3. Notice how the pre-image is 6, 6. Okay, so if I look at B, I go from 6, 6, and then B prime goes to a negative 3, 3. So I'm not going to worry about the negatives right now, but what I do notice is that my numbers are cut in half. So my dilation, I'm going to go ahead and say, my first step is dilation is going to be of a half. So I'm going to take that 6, 6, dilation of half is a 3, 3. Take my C coordinate 6, 2, dilation is going to be a 3, 1. And then I take my A coordinate 2, 4, goes down to a 1, 2. Notice how the triangle, all it does is it gets just smaller. And I can even label my points here too. So that's my first transformation. Put a 1 there just to keep track of it. Now I notice that it looks like all I'm doing here is I'm reflecting on the y-axis. For my second transformation. A goes 1 to the y-axis and then back over 1. B goes over 3, 3 more, and same with C. So my two transformations is dilation by half and a reflect on the y-axis. And then are the figures similar or congruent? They are the same shape, but they are different sizes, so they are similar. So I think these two are the hardest ones when you get shapes and you have to figure out what transformations happen. It does take a little imagination, and you have to work through it, and you may not always be right the first time. So if you're not right, just erase it, and you got to try again just to make sure it works. Okay. The next two I think are a little easier. It actually has your pre-image, and then it tells you what two transformations to do. So, and then we're going to go ahead and give our new coordinates with that one. So the first one is to dilate the object with a scale of half. So we're going to cut our coordinates down. So my A coordinate is a 2, 6, so that's going to go to a 1, 3. My B coordinate's a 2, 2, so it's going to go to a 1, 1. And my C coordinate is a 6, 2, so it goes to a 3, 1. So here is my new dilated shape. Okay. Then I'm going to go ahead and rotate it clockwise by 90 degrees, which means I'm coming over this way. So I'm going to take that shape and I'm going to turn it. So my C goes down 1 and over 3, which means I'm going to go over 3, or down 3 and over 1. So my C prime is coming over there. My A is going to swing around this way. Goes down 3 and over 1, so I'm going to go over 3, down 1. And there's my B, 1, 1. Put a 2 there for my second transformation. Alright, so I went ahead and dilated by a half, and then I went clockwise by 90 degrees. My new coordinates. A prime is 3, negative 1. B prime is 1, negative 1. And C prime is 1, negative 3. Alright, number 4. I've got to rotate the figure 180 degrees, then I'm going to translate it 5 up. So when I rotate 180 degrees, it's telling me to go counterclockwise. It doesn't really matter which way I go. One thing I do know about the 180 degree rule is that I'm taking my XY. Okay? And so let's go ahead and see 2, 2 goes to 2, negative 2. Okay? And then my A, 2, 6 is going to actually go to negative 2, 6. So all I'm doing when I rotate 180 degrees is I'm just making these the opposites. That's all I'm doing. Okay. B and then C. Instead of 6, 2, I'm going to do negative 6, negative 2. So that is my first transformation. Then I'm going to go ahead and do 5 units up. So 1, 2, 3, 4, 5. It's my C prime. 1, 2, 3, 4, 5. It's my B prime. And then 1, 2, 3, 4, 5. Here's my A prime. And let's put a 2 there for my second transformation. And then I have to go ahead and list my new coordinates. A prime is a negative 2, negative 1. B prime is negative 2, 3. And C prime is negative 6, 3. So there's my new coordinates. Alright, so what I'd like you to go ahead and do now is pause the video. I want you to try your own. You should have this in a handout, so you shouldn't have to copy anything down. So again, pause your video, try them. If you get stuck, erase it, try again. Make sure you just don't look at the video right away. I know these are tough, but you still got to try them. Alright, so my first one, we have what transformation or dilations have occurred. We go from our pre-image to our image. It looks like it enlarges, so there is going to be a dilation there. The first thing I went ahead and did though is I rotated at 180 degrees. That's my first step. So you can see I went 180 degrees. So there's my triangle. Looks very similar to this one. that's the same direction. My A's point in the same direction, C and B. It just has to now enlarge. And so to get my dilation of 3, I notice that C goes from -3, 1 all the way to -9, -3. So I increased it by multiplying by 3. Same goes for B. It goes from -1, -1 to -3, -3. And then A goes from -2, -3 to -6, -9. So my second is my dilation. And honestly, with this one too, if you want to do the dilation first and then rotate it 180 degrees, you could do that as well. You'd still be correct. Okay. So either way works. Number 2, we notice that we don't have a change in size, so we know there is no dilation to it. So that gives us our 3 options. I went ahead first and rotated it by 90 degrees clockwise. That brought it down here. All right. Then my next step was to translate it, and I ended up going 4 left and 2 up. And I said the figures were congruent because it's the same shape, same size. Number 3, it had you reflecting over the y-axis first. So let's go ahead and label these 2 D. Okay. So number 1 should have been what you guys got for your reflection. And then it dilates to a scale factor of 3, so you're going to increase everything by multiplying by 3. Notice how C stays in the same spot, C prime there, because it's 0, 0. Whenever you multiply by something, it just stays at 0, 0. So my new coordinates were 0, 9, -6, 9, -6, 0, and then 0, 0 for my C. All right. And then number 4, you guys actually had 3 transformations to do. Okay. So your first transformation was to rotate it counterclockwise by 90 degrees. So I labeled it number 1. You should see that box should kind of drop on its side, I guess you could say. Then it translates 6 units down. So I took it and counted down 6 for all of them. So I have a 2 next to there. And then lastly, we have to reflect over my x-axis. You can see here I made the mistake of reflecting over the y-axis first. Scribble it out, and I reflected over my x-axis, making sure I always do the right one. Your B is your 4 away, so you go 4 up. D is 4 away, so you go 4 up. C is 6 away. A is 6 away, so you go 6 up. So my new coordinates for this one should be A is -3, 6. B is -3, 4. C is 0, 6. And D is 0, 4. When you guys are doing these transformations, please make sure that you are following them in order, step by step. If you try to do 2 at the same time, it's going to get very, very complicated for you.